Okay, here we go. I'll bring up the notes in just a minute. So you should have notes out for objective 13. Just wanted to mention a couple of things. So con that is due tonight that we assigned last week, there's a couple on there that are kind of challenging, just like what are they looking for answer-wise, okay? So I was just explaining what it's in black, real small on the board, but it says I'm only counting 400 because there's 5 of them, right, that you're doing, so it's 500 points, but in the grade book I'm only going to count 400 points. So if you do all 5, that means you're going to have 100 extra credit points, okay? The reason why I'm doing that is I know 2 of them were kind of a struggle, okay? So if you can get some points on both of them, you should be able to get to your 400 points. If you get so frustrated, don't get frustrated, okay? The idea behind using con is so that you see it differently than what we're doing on the board, okay? Because it's really hard to prepare you for any type of ISATs or SATs or PSATs or anything like that, college entrance. I can't do an example of every type of example that you're going to have out there. So with using con, you'll see something different than the story problems that we have on here. So it's about you like putting together what we've got and having a struggle, okay? Because it's okay if you miss it, because the nice thing about con is you can hit the hints and see the process and then go back in and do it again, okay? And that's the best way for you to learn is by missing something actually, because you learn from your mistakes, okay? So that's what that, you'll see 400 in the grade book, but there was actually 5, so it'll be 500. You could have a potential extra credit. So some people say, well, I got a 75 on one of them. Well, then you got 475, so you got 75 points extra credit. Okay, so that's what that when the cons do now. Today's notes and the try it. Today's notes and the try it are really short. Okay, so you should have time if you want to get back in there and work on the cons to try to get some of those extra credit points. You can. If not, you'll do it outside the class, but we will be creating a try it because it's super short. Okay. Good to there. Okay, so, one more thing. So something that, and I didn't notice it until later on the day when people were pointing things out on the graphing. When we've been graphing, and don't write this, I'm just explaining this because it'll appear in this one. When we're graphing things, we've been used to either them going towards each other, right? Okay, or going the opposite direction, okay? But then you notice when you did the multiple choice, it was really hard to see. Because typically when we graph things, we don't take it off the graph, okay? I did that just sort of notes-wise. We're not like scribbling all over our graphs and stuff like that. So when you did the multiple choice, they had a number line, right? And we had multiple dots on there, whether they're open or closed. And then it went this way and this way, but instead of them showing up above, they just did one full line and you couldn't tell, okay? So that's actually going to reoccur in this section. You're not graphing in this section, but there's one of them that you need to be able to visualize what the graph looks like. Because when they talk about that it needs to happen in both equations and where your line is, so like this one, when I graphed this one, it went to the right. These numbers right here, okay, these ones right in here are only going to work for that equation, okay? This one right here, when I went to graph it, all the numbers to the right would work for it, and then also all these numbers to the right would work for this equation. Okay, and I'll show you when we go to do that. Okay, and that's where that kind of came in, and it's a little bit of a carryover from the last section. Okay, again, you won't be graphing, but you're going to need to know how to answer an equation with thinking about the graphs in mind. Okay, all right, and I'll put this all together when you actually see the problems. Minimize that one. And lucky you, this section is word problems, so that's why we separated them. Okay, so objective 13. So when we come across the word in the word problem and it says at least, it's actually backwards the way we write it, because that's really greater than or equal to, and I'll show you where the at least comes in when we go to actually write the problem out. So at least is that symbol. And then in the story problem, when you see at most, it's actually the less than or equal to symbol. And then exceeds is greater than. So it's kind of like opposite of what you see. Okay, because at most you would think, or at least you would think would be the smaller part of the sign facing on. Okay, we good? Okay, so you're going to write the story problem out. Okay, and this one was not on the notes, and it was not on the try it. It was in the multiple choice, so that's why I put MC, because you'll see it in the multiple choice one. And so this reads 3 times the difference of a number and 13 is at least 81. Let X represent the number and find all possible values for that number. So I'll let you write that down. So in reading these, it's different than our last section. We actually had the equations written out for us. So now we've got to write the equations and then solve them. Okay, so this says 3 times the difference of a number and 13. So it doesn't say 3 times a number, because that would just be 3x, okay? So how do we write this one properly? 3 times, what does difference mean? Subtraction. Okay, subtraction. So sum would be addition, which it doesn't have another. So 3 times the difference of a number and 13.
So 3 in parentheses, x minus 13.
There's parentheses involved. 3's on the outside. X minus 13 in the parentheses. Okay, so we've got to find the difference first. Okay, so whatever variable you want to choose, doesn't have to be x. So finding the difference of a number, okay, finding the difference of the number in 13, and then timesing it by 3. Okay, so this is now where you're going to look at your symbols, and it's at least. Okay, so the at least is opposite. It's not the smaller part, it's the bigger part facing this way. Okay, 81. And so the reason why it's this way is the smallest it can be is 81. So that's why the smaller part of the sign faces 81. Okay. Well, when you read that word, that phrase, you would think it'd be flipped around. Okay. But it has to do with the 81 and not what was before. Okay. So now we're just solving that one. Okay. So we're going to distribute. So I have 3x minus 39. Okay, then I'm going to add my 39 over to the other side. So then I would have 3x is greater than or equal to 120. And then divide by 3. So x is greater than or equal to. Okay, so no graphing, just learning how to write these and what they mean. One of these will graph just because we have to answer it by looking at a graph or thinking of it inside our head. So, okay, we good? Okay, so next one. This is actually one of them that you'll have today. Okay, so this reads 4 times an unknown number is at least 6, and 9 more than the number exceeds 6. Find all possible values for the unknown number. So we're going to have 2 separate equations on this one. So I'll let you write that and then we'll talk about it. Okay, I'll go ahead and get started on this one. So this one's actually a little bit easier to write than the last one. So it just says 4 times an unknown number. So what would that look like? 4x. Okay. So 4x, and then we have the at least again. So it's not the smallest part of the sign facing this direction. It's flipped. Okay, it's at least 6. And now we have a separate equation, okay? So now we have 9 more than a number. What would that be? X plus 9. Or 9 plus x plus 9. So x plus 9. Okay, and then exceeds that we have greater than. So this exceeds 6. So the smallest it can be is 6. It has to be bigger than 6. So that's what the exceeds. Okay, so now we just solve them separately. Okay, so I would divide by 4, divide by 4. I'm not switching my inequality because I didn't divide by a negative, right? Okay, this would wind up being 1 and 1.5 or 1.5. And then you have calculator, let's do it for you. Okay, next one, subtract 9, subtract 9. Not switching my inequality. Okay, so on these where you get 2 answers, we have to know how to write the answer, okay? I'm going to give you the long version, okay, and tell you this is what you're going to see when you go to do the multiple choice. You are not going to have to do that because a bunch of it previous to that really is kind of nonsense. You're really wasting time. So really what I'm just going to have you do is circle which one of these is the right answer. And this is where it comes from, okay? if we were, you don't have to graph it, but if we were to graph this, we would have a closed circle at 1.5, right? So we'd have a closed circle at 1.5, and x is bigger, so it'd be going to the right, right? So we're going that way. Okay, then I have an open circle at a -3, open circle at a -3, and x is getting bigger, so it's going in the same direction, kind of like what you had on some of your stuff the previous day, okay? So they want to know what is working in both of them. It has to work and. It's not one or the other, it has to work in both, okay? So I'm not going to be using any of these numbers right here because these numbers are not going to work in that, right? Because if I were to pick, like say 0, make 0 the easy one. So if I put 0 into this equation, is 0 bigger than 1.5? No, okay? So none of these numbers work. So it's where they meet at. So where they meet at, visually, if you were to look at a number line, okay, that is the equation you're going to use. The equation you use. Okay, so where this one and this one meet at, okay, that's where they meet at. So that's where it starts to work in both. So even if I went to a whole number and put a 2 in here, is 2 greater than a -3? Okay, is 2 greater than or equal to 1.5? Yeah. So basically everything from this dot to the right works, okay, which is this equation right here. It was this one that we graphed that was to the right. That equation works for both of them, okay? So anytime you have those, you just need to know, if it's going to the right, basically it's going to be the furthest one that you graph to the right. If they're going to the left, both of them are going to the left, then it's going to be the furthest one to the left is the one you're going to pick. Okay, so you can just circle it. Okay, this is what you're going to see when you do the exercise. So I want you just to add it on there. You will not have to write it like this. So they put that J Leno looking face bracket. Okay, and then they have X. So any values of X that you're plugging in, it will be the set of all this is set. That's what that symbol means. It's like a C that looks like an E of all real numbers. And then they'll have a comma, and then they're going to write that equation because they just found the answer is greater than or equal to, and I'm just going to put 1.5, and then they end the J Leno. Okay, so go ahead and write that so that you have that. So when you go to do the multiple choice, you know that that's what you're looking for. Okay, so the way that that reads is any value for X when plugged in is going to be the set of all real numbers when X is greater than or equal to 1.5. That's what all of that means. You do not need to write it that way. You could just solve the 2 and then tell me which one is the right one. It'll just be easier. But when you see that, that's what that means. We good? Okay, next one. So the width of a rectangle is 17 centimeters. Find all possible values for the length of the rectangle if the perimeter is at least 652 centimeters. Talking with some of you are finishing writing. Okay, so in rectangles, we know we have 2 sides that are the same, right? The opposite sides are the same. Which one's the L, which one's the W? That part really doesn't matter. Okay, so I'm going to call this one my W. So this one would be the same. Whatever they are going to be the same length, okay, because it's a rectangle. And I'm going to put this as the L. Okay, so instead of when we're doing perimeter going L plus W plus L plus W, we know we have 2 L's and we have 2 W's and we need to add them together. Okay, it's another example of perimeter versus the sum of all the sides. Okay, in our description that we're solving things, it says the width of the rectangle is 17. So I already know what one of the variables is. So the width is 17. Okay, but now we need to write it as an inequality, not as an equation with the equals. Okay, it says find all possible values for the length of the rectangle if the perimeter is at least. So remember, the at least one's not this way, right? It's going this way. Okay, so we're going to write this equation. So we're going to go 2L plus 2W, and it's not the small part of the sign, it's the big part of the sign. Okay, and they gave us the total for the perimeter being 652. Okay, so I already know what W is. Okay, so if I know what W is, I'm going to plug it into the equation where the W is at. Okay, because I have two of them. Okay, so I'm going to combine or simplify the multiplication part. So 2L plus 34 is greater than or equal to 652. Subtract my 34 over. So now we've got 2L is greater than or equal to 618. Okay, then divide by 2, divide by 2. So L is greater than or equal to 309. And I'll have centimeters when you go to do it. I'm not going to check your labeling as long as you have the sign and the symbols go in the right direction with the number. Okay, good? We're going too fast? Okay, last one. Similar, but a little bit different because now we have a square. Put square on my screen, but it doesn't up there. The perimeter of a square is to be between 13 and 52 feet inclusively. So we're actually going to write one equation versus two separate equations. And it says find all possible values for the length of its sides. So what do we know about a square and its sides? They're all the same. So we're not going to have an L and a W. We're just going to have whatever variable you choose, and it's going to be 4 of them. Okay, so I know I have all these sides being the same, so it'd be x plus x plus x, or I can just go 4 times whatever the x is, okay? So I know I'm using that, okay? The smallest that the perimeter can be is what? 13. Okay, so we write the smaller number first, and then the smaller part of your inequality sign is going to face that number. So if this is the smallest it can get, then I need to make sure the small part of the sign is facing 13, because it can't get, that's the smallest it can get. Okay, so the biggest it can get is what? 52. Okay, so the biggest part of my sign is going to face the 52. So inclusively just means somewhere in between. This is my smallest, this is my biggest, but anywhere in between this would work. Okay, and that's the way that we have set it up. So one step on this one is what? Divide by 4. Okay, so divide by 4, because that's what gets my x by itself. Okay, so that ends up giving me 13.25. So that's the smallest the sides can get. Okay, all the way up to the max, which is 13. And that's it. So every single one of those, they'll have the smallest number first, second number, your biggest number. Just make sure your signs are facing the right way. Smallest pointing to the smallest, the biggest part is facing to the biggest that it could be. And I'm not sure. I don't think they're too bad. Okay. All right, so working on the try it, we'll grade it, last 5 or so minutes of class. And then so if you get done early, you're working on con if you haven't finished that.